Hey guys, Doug here. Have you ever wondered how YouTube is able to notify all of the subscribers that have clicked the little bell button down below when a new video comes out? A super easy way that this can be handled is by implementing a topic. Some of the most common topic implementations are by RabbitMQ, Apache Kafka, and Pulsar. In my previous video about JMS queues, I said JMS can be implemented as either a queue or a topic, but today we're just going to be focusing on the queue. The other will be a topic for another video. So what is a topic anyway? If you're familiar with design patterns, a topic is just like the observer pattern, except instead of transferring information in between different classes, it's transferring information between different applications, and it's usually hosted remotely. If you have no idea what design patterns or an observer is, I recommend getting a copy of Design Patterns by the Gang of Four. I'll put a link in the description. In its simplest form, a topic is a structure that takes one input data and it sends that data to any number of subscribers that are subscribing to the topic. The exact same data is received by all of the subscribers on the topic. This is much different than a queue. A queue allows for a single message to be consumed by a single subscriber. However, a topic is more like a broadcast. Anyone who's listening can hear that exact same message and take some action. When we talked about queues, we talked about how a JMS message has specific parts. Well, when you're talking about topics, they don't really have any specific structure like a JMS message or like an HTTP message. However, that might vary just a little bit depending on the implementation of the topic you're using. For example, if you're using Apache Kafka, you might include something like a group ID or a keyed message in order to tell the Kafka instance to do something specific. But if you're using something like RabbitMQ topics or Pulsar topics, those headers are likely going to be different. Let's take a quick look at how a topic compares to a queue and HTTP. The clear benefits of a topic are its ability to notify any number of subscribers about a new event or change, its durability, and its replayability. For example, in Kafka, all of the data is stored in offsets inside of the topic. You can think of offsets like an index in an array. So if you ever need to go back in time and replay a message, you can simply start a subscriber from a previous offset instead of subscribing from the very latest offset. However, HTTP is still much lighter weight than a topic or queue implementation. And that's because most frameworks that people are using to build applications come with an HTTP server or client baked in already, and there's not a lot of additional overhead required in order to send HTTP messages. When it comes to subscribers, there are really three ways to set up subscribers for a topic. The first way is to have a bunch of different subscribers all listening to the same topic. When this happens, each one of those subscribers gets an identical message and can do whatever processing or storage that they need to do. Usually this is referred to as a fan-out type of subscription. The second type of configuration you might see for consuming messages from a topic is to put a bunch of them into a consumer group. When you do this, instead of all of them getting the same message at the same time, they'll take turns in sort of a round-robin fashion, operating on each message one at a time. You might see this happening if the order that something gets processed from a topic subscription is really important. This can also happen if the consumer needs to do a lot of really heavy work. You might need multiple consumers consuming from that same topic in order to get everything processed in a reasonable amount of time. The third type of topic consumer that you might see is having a single consumer that subscribes to a whole bunch of different topics. This is pretty uncommon, but this could happen if you have a bunch of different topics, but there's not a lot of velocity for each one of those topics. So you don't need a bunch of different consumers. You can use a single consumer that's looking at all the different topics and it's taking its time processing the message from each one of them whenever something comes in. Think about it like this. You could be a single consumer and all of the different YouTube channels that you subscribe to are different topics. Because a lot of those topics or YouTube channels might only publish a video once, twice, maybe 3 times a week. It's really easy for you to consume all of the content from those different channels because they're only publishing things a few times a week. I usually run and manage my own Kafka instance, but Confluent makes this really easy if you want a solution that's managed. Another common one is Amazon SNS. Now, I haven't used this one personally, but it seems like a really popular one for those who like to stay inside of the AWS ecosystem. Now that you know how topics work, go out and make a project with it. If you want to know more about message queues, check out my previous video. Thanks for watching, happy coding, and I'll see you in the next one.